we're actually missing a lot of brilliant people who can contribute and advance so many fields by turning them off so early on with math and making them think that math is just an exercise for few people who are geeks or a bit arrogant sometimes that they can do math and they can do this, like write these symbols. So no, I think you're right. It's we have to change the way we teach it.
I'm excited to welcome Hala Nelson to the Data Bites podcast. She is the author of Essential Math for AI and also a professor of mathematics at James Madison University and has done numerous work around AI and data strategy. So we're going to have a really interesting conversation today. Hala, welcome to the Data Bites podcast. So where are you joining us from today?
Thank you, Sadie. Thanks for having me, inviting me, and all the work that you all are putting out there. I am today in Alexandria, Virginia. That's where I live. And the university I teach at is actually 2 hours away from me, Harrisonburg. So I'm never really where I work, always some places. But today I'm at home.
Now, do you teach many of your classes remote, or what does kind of your schedule look like on a day-to-day basis as a professor?
Yeah, for teaching, I go to school. I go twice a week, so I kind of bundle all my teaching in these two times. And sometimes the class is fully in person, sometimes it's hybrid, sometimes fully online. It really depends how the class is structured and how much, um, like real life project classes, they actually need me with them in class doing the stuff. And classes that are more like structured, and it can be online, in person, hybrid. It depends on the scheduler.
You are the author of a book, Essential Math for AI. And I think this is such an important topic because, well, everyone is talking about AI. Sometimes the mathematics behind it get missed a little bit. What made you want to write this book? And for our audience who hasn't read it, can you give us a little overview about what it's about?
Yeah, I mean, I wrote the book because I felt it was needed. I needed it first and foremost, and I realized that the AI was blowing up. It was like I feel I kind of noticed it 2 years before it started really taking off. And I'm like, I'm interested, and I would love to do projects on that, teach courses on that. I see the potential is huge. Anything that can automate processes has big potential if it can be done fast, with efficiently, and without costing much money. So I saw the potential, and then I realized that everything out there is all about the models, like the details of the tiny models, and there is nothing that ties these things up. So people are getting lost. There's so much information. You're like, is this model or that model, and this, and then people come up with new adjustments, tiny adjustments for one model, and they blow it up and multiply that by 100, and you really have one big mess. So it's not how I operate, and I did want to organize it a little bit more. So it was coming from that need to find out what is the core things that are happening here. What are like the 4 or 5 things that I need, or some of my students need to know, anyone who wants to enter the field, leverage the technology, needs to know in order to study these, and then everything else would be a variation. So I ended up structuring the book that way, around the types of intelligence, what makes us intelligent, how do you model that, and what kind of families of models exist out there. And then you realize it's only 2 or 3 families. And then once you get to the core, you suddenly are seeing the whole field from above. And so it was an ambitious project. When I first started it, people told me, this is too ambitious, this is a lot. But yeah, it ended up resonating, and I'm grateful to have noticed something and just dove in. I jumped head first. Yeah.
When you think about essential math for AI, what do you recommend individuals start learning, right? There's so many classes out there. Is it linear algebra? Is it calculus? Where's a good kind of fundamental starting if you really want to dive into the mathematics behind these models? Where should one start?
Mm-hmm, mm-hmm. Yeah, this is a great question. So I definitely, I'm gonna list three things: calculus, linear algebra, and probability. However, I would advise the moment you're learning the subject to immediately try to connect it with the AI application. Do not study these subjects alone as mathematical objects, because can be ultra abstract, but the moment you see its connection to what you personally care for in your application, whatever field you are in, when you draw that map, that's when it sticks in your head. And so it's true, it's only these like 3 4 subjects: optimization, part of calculus if you want advanced calculus, but but you do need, my advice is always, I even have my students do that in every single homework: connect it to your immediate applications, come back, tell me how it relates to your future career. So that's how I end up structuring it. That's my always advice.
Do you think that's one of the reasons that so many people struggle with mathematics is it doesn't get translated back to an application area for them in class? And so it's like, okay, yes, I learned this formula and I figured out how to do it, or maybe even I'm struggling with how to do it, but like, where does it apply? Because I've heard so many people that they really fell in love with mathematics when they learned statistics, because I think statistics does a really great job of like applying it to populations and measuring populations, right? But do you think that we're missing out in teaching mathematics because we don't apply it to areas and show people how it's really used?
100%. We're missing a lot. We're actually missing a lot of brilliant people who can contribute and advance so many fields by turning them off so early on with math and making them think that math is just an exercise for few people who are geeks or a bit arrogant sometimes, that they can do math and they can do this, like write these symbols. So no, I think you're right. We have to change the way we teach it. We have to like motivate it all the way, go back to the root, motivate every single thing we're using, and draw these bridges. It doesn't take that much more time in the class. And I mean, people, when we suggest that, they think we're suggesting to change a whole curriculum. I mean, no, it's just tiny changes in the classroom. Just add a bit topics, ask the students to do a bit more connections, and you'll see they'll come out and they would love it. They would contribute. And statistics as well. It's I mean, now is the time to be like a glorified statistician in a way, with like blown up data, and we can use it for all kinds. We can apply it on we can integrate data in ways we never dreamed of before, whether it's the volume of the data, whether it's the actual amount of features that you can bring into it. So this is the time we have a chance as educators to like retain all these brilliant minds. I really believe in the human mind. I've taught thousands of students, all kinds of backgrounds, all kinds of economic levels, all the way brilliant, and all people who thought they weren't. This is not cut for them, but the human brain is amazing. We all have our own ways to learn, and we need to believe again in that.
When you think about mathematics, so many people have like this fear of it or already have identified with this, like, I'm not good at math, right? I think people fall into two groups. They're like, I'm not good at math or I'm not creative. You hear those and they just shut everything out, almost like by saying that, you like shut yourself off from ever learning it, right? And I love what you said. There's so many people who have these brilliant minds that we're missing out on being a part of the equation. And particularly, I think in AI, a lot of people are like, I'm not good at math, so don't dive into the area. What advice do you give for those people who, like, maybe in the past they identified as not being good at math? How do you start to change that story and where do you get started?
When they start, I always believe in like goal oriented. It's like when they start addressing something that's sticky in their job, or they need to solve a problem that they have not solved before, and then ask questions, and also never think that just because this other person knows something, it means that you know less. It just means you have a different brain, and we just change your attitude about yourself and what you're capable of. Always be wonder of the human brain. I mean, that it's your brain, their brain, we don't operate the same. I was never a typical student, and I never am until now a typical professor. And a lot of the times people didn't even believe in me, and they don't owe me to believe in me. I don't owe them that to show them anything, right? But we're all different, and accept this difference. And but then the most important is specify what question you want to answer, whether it's this data set you want to do something with it, whether it is something that I don't know, you want to use a model that someone else wrote without you needing to even dive into detail. So specify the question and specify the level of technicality that you think it would require, and then start from there, and then start looking for information in the right places. And I taught myself, and I taught my students how to teach themselves. I tell my students, I'm not here to teach you like how formulas or models or AI. I'm teaching you how to teach yourself. And that's when and to actually, because we all are different, trust the way you are and go with it.
A lot of individuals, particularly in the education of space, have been kind of questioning, like, what do we teach people with now all of AI's capabilities, right? It can write, it can reason, not at the high mathematical concepts, right? But how do you think the advancements that we have in AI today will change, particularly mathematics education? And what will be some of the pros and what will be some of the cons of it?
I love it. I love the changes. I've always been happy to adopt anything that makes boring things faster and makes us free to do like the stuff that we really like stimulate us and make us really want to dive in and think. So I find the fact that AI can do anything that is you can give it ideas, say, and it creates a whole paragraph for you. Whether that's good or bad, you are the judge now. So you become like an editor. If you're a writer, you become an editor. If you are if you're like reasoning, creating or even you're in business, you want some ideas for businesses, it pops it out for you. Whether it's language, whether it's you're making slides, I'm not using it myself, but I can see the benefit of going in the direction of accelerating things that usually take longer, and then having the rest of the space. Because if you ask me like how many books you want to read, I want to read 100 other books than the ones I have. So if I have time more, I'm gonna if I want to exercise, if I want to go to a spa, who knows what you want to use the time for. But in terms of education, there's always stuff to do with students. You end up, when you automate part of your course, and part of their how much time they're going to spend on coursework, then you have more time to connect with the students and connect the teaching. I've noticed in my automated courses or in my project based courses, it becomes personalized, and that's always amazing, because that's when I'm really able to connect with each student, what they want to do with their career, what they expect to get out of my class. So before that, some level of automation was available. As a professor, you have a very limited time with so many students, and then you have to kind of teach with averages as opposed to teach with personalized. So I find it amazing. It's great. It's great to have time. And I don't know anybody who is at their job wouldn't want a bit more time. I don't see, you know.
I completely agree. I mean, I think if we look back and just look at the way we worked 40 years ago, right? Like back in the 80s, things were much slower in the way that we worked. We didn't have as fast-paced communication. And I think if a lot of us were placed back in that time of having worked in today's day, we may be very frustrated or be like, oh, I don't want to do all of this or have to write on a typewriter or, make phone calls and these types of things, right?
Yeah, or filing things, right? Like how much even in actual data collection, even compute, right? People in computers were human beings actually doing the computations. So these were the original computers in the Second World War, so it's really amazing how far we've gone. We shouldn't like just hesitate only because this is too fast, this is too powerful. Okay, I am with all of these considerations, but it doesn't mean it doesn't benefit us. The whole world is converging on this technology because anytime humans were able to advance in computation and data aggregation and data drawing insights from data, they've made like a civilizational leap, right? So it's always advanced our societies tremendously, and this is bigger because in a way we can now talk to our data. In a way we can converse with our data and draw insights the way we talk with other humans, as opposed to waiting for the team to pull up that. I mean, and I'm not saying we are at that level, I'm saying that's hopefully where we all are headed in, with these language models, with these data marketplaces, like all the with the reasoning, with the graphs, with all of that. So that I see the potential, and that's why. So the thing about math, if you're a mathematician, you're never like riding a wave of hype, or kind of you're kind of okay, what's true here and what is valid, what do I see, does figuring out this computation or at that scale, does that help the world or not? And I can see these a lot of things coming together nicely in that direction.
I think that's such a beautiful point about math and also an encouraging point of why people should learn it is it's kind of like this hype filter or this like truth filter, right? That no matter what comes, you can bring it to the computation to be like, is this true and is this valid? Which is like such a comforting thing in our world today, given so much noise and so much information.
Exactly. It is a noise removal shit, because we have to at some point sit down and see if it adds up. Like someone has to sit down and do the calc. Does it add up? Is what they're saying going does it have any merit? Do the models really say that? Did they have this GPU that can do that calculation at that level, right? So you have to sit down and like kind of see it through, see if this like they use words like transformative, disruptive, etc. All of this like business world where you're like, okay, does it really do that? Let's see. Well, what would it require? What should we sit down and do with the data for it to require? So you kind of like someone has to get their brain kind of in the like, yeah.
So I can tell that you're very much a fan of the progress we're making in this space. And I believe you're also writing another book now about prompting and helping people with that. Can you tell me a little bit more about what this book is about and where it came from?
Yeah, so the new book, so when I wrote the Essential Math for AI book, I was fully concerned with the models and their applications, their real life applications, and what technologies they kind of go into and contribute to. And then when I was doing that in the process, I realized the more I understood, the more I realized I have a gap in the actual intersection with the data pipelines themselves, like the data engineering part. Like I did not get that intersection between the models and exactly where do they fit in a production pipeline, in any kind of use case, or at the organizational level. Say I want to transform the organization with AI, like everybody says. Well, where is the AI going to fit, and how do their actual IT landscape look like? And I noticed there were some gaps between the actual AI models that do magic when they get the amazing data, and the actual amazing data, what's happening with it, and can AI help in those pipelines as well, wherever they get stuck, wherever. So I noticed there is an end-to-end story, and I'm not saying like I wanted to dive in every single algorithm or nitty-gritty, but I wanted to explain like the whole landscape all the way from down to the hardware level, like what Nvidia is doing, why is it important, and why is it that these GPUs had to be bigger, and where were the bottlenecks that this hardware is addressing, at the level of hardware and even materials like the supply chain, the semiconductors, the even like if you want to be even more minuscule, there is a quantum side as well, like exactly how does that differ from the classical mechanics side in terms of the actual technologies. So there's this like down the hardware, and then on top of it there is the databases, etc., and then the models, and then the applications, and then the strategy in business. So I was like, I wanted to kind of tell that story in a coherent way, but only AI focused and data and human as well, the role of the culture, the role of humans. So I do see that as kind of like sectioned and telling. And I feel like who you were asking, who wants to get in this field, that would like be a nice introduction to all of these ideas, and then wherever they end up fitting, they know the rest of the story. They don't feel like there's a million things they don't know. At the same way I did it with the math and AI, about the million models out there and how to improve them. My plan was to do it with kind of the infrastructure all the way up to the organization and strategy.
That sounds amazing. I'm such a big fan of seeing the bigger picture of things, and it really sounds like this book is putting all those pieces together, right? Like we know that AI revolution is making Nvidia stock skyrocket and everybody wants their hands on it, but why is that so essential and how has that enabled us to get to the point of where we are today? So I'm really looking forward to checking out your new.
Thank you. And it will help people also see where they and their whole job fit in the whole piece. And that makes them more passionate. They make them contribute more. They make them make a jump if they ever want to make a jump. They make it comfortably because they kind of know the bigger landscape. As you said, seeing the big picture is, as always, how I operate.
I love that. I think it's going to be such a great resource for people. And just as you mentioned, to be able to see, like, where do I want to fit in this equation? Because the landscape is so big and there's so many roles and opportunities for individuals. Speaking of roles and opportunities, I'd love to hear a little bit more about your journey into this space. Was mathematics always a love of yours, or how did you fall into the role you are today?
Wow. Yeah. So that is another book I'm writing. People keep asking me to write that book, so I'm actually finally get telling some stories. I'll tell you some stories. I'm from Lebanon, and my dad is a math teacher, high school math teacher, and I grew up in Civil War, so we would actually not go to school a lot of the time because you never know when things blow up. So my parents, my mom is an English teacher, my dad is a math teacher. So they ended up, all these days we spent at home, they ended up teaching us. So I grew up learning math. Very in a very untypical way, just sitting next to my dad with a huge math book that actually had all the math for all school for all grades. So it was a really nice book. It was in French, and yeah, so I'd be solving problems, and I enjoyed it a lot. And I kind of enjoyed the freedom that comes with math because you're not like tied to a lab or an office or a workplace. So I kind of always notice that because we just sit, do math, and go and play, and then come back and just, so that really affected like the fact that of how much freedom you have while at the same time solving problems with all kinds of applications. You see it everywhere, the application. You can actually, I do believe at this level that math is the a language that can explain the whole universe. In any process, you can actually model it mathematically. And to me, that is magic. And that is not something that I can explain why it is. It just is and out there. So yeah, so this is how I ended up. It was the natural choice for me when I went to college to do math and to stay free. And then I ended up, long story, I ended up doing my PhD in New York City. It was a long journey, a very different culture, very different everything. But yeah, here I am. I did PhD, I did postdoc in Michigan. I'm now a full professor at JMU. So there's a lot of stories to go in there, but this is like the highlights.
Yeah, well, I mean, it sounds like an amazing experience to be able to have two incredible parents, with both teaching experience and background, and it. I'm just really excited about that book too, to hear about your journey and how you've gotten to where you are today. As we get close to wrapping up here, what advice do you have for young people? Uh, just given kind of the environment of our world today, having been somebody who's lived in a turmoil environment and been an immigrant and transitioned in school and also been a woman in tech and AI, I think you're just a wealth of knowledge. What advice would you give to people today?
Yeah, I would say be true to your heart. Anything someone is saying, and you know, or a whole, sometimes a whole society is headed in one direction. If you're in it, you do want to like step back and look around you and kind of take it to the maximum in your head. You're like, if this thing keeps going on a bigger scale, how does the world look like? And where do I fit in it? And would I still fit in it? And that's really the exercise I did in my brain when I was in Lebanon. When I decided that I had to leave, I felt it was unsustainable. And people will make you doubt yourself very well. And sometimes the fears are real. It's not, they're not instilling not real fears on why you should pursue this path and not that path. But again, if you step back a little and do the mental exercise with yourself, with your heart, see like, and also do find the people who can answer your questions and generous with their knowledge. I cannot, like, there are many people out there who are not generous with their knowledge. A lot of people are generous and want to help you, and so do find these people. And then the others who don't help you or answer a question, they don't owe you. You don't sit down and wallow and say, oh my god, my life, like they're just like, always surround yourself with people who you really value and add to your life. You add to them, whether it's in your career, whether it's in your studies, whether it's in your personal life, whether do, and we all are unique. Believe in your own strengths and weaknesses and know yourself before you actually know yourself as you do your journey. And I think this is a bit deeper, but kind of like, if I have to distill, like, what is it that helped me overcome 100 million things and also be myself in tech, in whatever field I want to. As a writer, like, I never wrote a book before. I'm like, oh, I'm gonna write a book, and I just, submit a proposal the next day. So whatever it is, like, know yourself and always look for these knowledgeable people around you. We are social beings, and we are who we are in the end.
I love it. I think that is fantastic advice and just great advice that will be helpful to whatever life brings an individual along the way. So, Hala, thank you so much for taking the time to come and chat with us today. This has been a pleasure, and I can't wait to continue to read more of your books and follow along and cheer you on in your journey. So, thank you.
Thank you, and I will be reading your book as well.
Thank you. And to all of our listeners, a big thank you as always. Remember to stay curious and keep learning. And we will catch you next time on the Data Bites podcast. Bye bye, everybody. If you are enjoying the conversations you are hearing today, we encourage you to continue to be a part of the conversation and join a community of like minded, extraordinary women. With our free community membership, you're stepping into a realm where learning, networking, and growth are at the heart and soul of what we do. Connect with Women in Data's global community and network with our chapters all for free. But why stop there? Upgrade your membership with a special offer for Data Bytes listeners by getting $20 off a pro membership, in which you'll receive access to over 300 classes, leadership training, and exclusive events. If you're interested in mentorship and networking, we've got you. From monthly thought leadership webinars to exclusive networking events and a diverse on-demand mentorship program, the connections you'll make here are boundless. Join us and be part of a vibrant network. Dive into our book clubs, growth groups, and industry-focused gatherings. Women in Data is not just a community. It's a movement, a place where innovators, changemakers, and leaders come together to shape the future. Visit womenindata.org to join or use the special discount code in the show notes. Together, let's drive change one data byte at a time.